Welcome to today's custom deep dive. Whether you are prepping for a high-stakes board meeting or, trying to catch up on the bleeding edge of industrial tech, or maybe you're just insanely curious about how the massive systems running our world actually operate, well, you are in exactly the right place.
You really are. We've got some fascinating material to dig into today.
We really do. We have something genuinely groundbreaking on the desk today. Today is July 1st, 2026, and we are looking at a brand new press release alongside this incredibly detailed white paper from EON AI Ventures.
Yeah, and the title of their paper is The Living Library, which I have to say is quite a hook.
It totally is. And our mission today is to explore this massive shift in how heavy industries operate. Because we are moving away from software that just, catalogs parts, to an AI that actually acts as an experienced colleague who understands the physical work.
Right, which sounds a bit like a fantasy novel at first glance. But the implications here are about as real and grounded in heavy industry as you can possibly get. I mean, for decades, industrial knowledge and digital models have basically lived on completely different planets.
Right, because when you think about the heaviest, most complex industries on Earth, let's say an oil rig out in the North Sea, or a sprawling petrochemical refinery in Texas, you tend to imagine these environments as perfectly orchestrated machines, right?
Exactly. We picture this endless, pristine archive of manuals somewhere.
Yeah, like the pipes are heavy steel, the investments are in the billions, so we naturally assume the knowledge of how to run them must be bulletproof, perfectly documented in some highly secure vault.
We assume every single scenario, every valve turn, every pressure drop has an exact written procedure that engineers just follow to the letter. It feels like it has to be an exact science because the stakes are just so incredibly high.
But then you actually talk to the people on the ground. You look at the engineers working in the mud, the wind, and the deafening noise, and that illusion of perfect documentation shatters pretty quickly.
It shatters instantly.
Yeah, you realize this terrifying truth. A massive chunk of this global infrastructure is essentially running on the unwritten instincts of a few veterans. It's just gut instinct.
And those veterans are practically sprinting toward retirement right now.
Which sets the stage perfectly for what EON AI Ventures is doing. Today's announcement introduces the Work Intelligence Library, which is the core of their EON Universal platform.
Right, and its entire mission is to merge those two isolated worlds. As I mentioned, you had your 3D blueprints in one system and your training manuals in a totally separate filing cabinet. EON wants to bring them together.
Okay, let's unpack this. Because my immediate reaction when I read the phrase experienced colleague in the press release was deep skepticism.
Which is a totally fair reaction to have.
I mean, massive industrial companies already use 3D models every single day. They already have digital twins of their facilities, right? And they have millions of dollars invested in training software. So how is this library actually doing anything new?
Well, to see the breakthrough, we really have to pull back the curtain on the severe limitations of that current technology. We have to look at what those existing tools fundamentally lack.
Thinking about this, a totally non-industrial analogy popped into my head while I was reading.
Oh, I love a good analogy. Lay it on me.
Okay, so traditional industrial software is basically like looking at a high-definition photograph of a professional Michelin star kitchen.
Okay, I'm with you.
But this new Work Intelligence Library, it's like having the master chef physically standing next to you in that kitchen.
That is the perfect distinction. The photograph shows you where the stove is, sure. It shows you the layout.
Exactly. The photo, which is the current tech, shows you the stove, the fryer, the sink. But the chef actually knows that if you turn that specific stove on while the fryer next to it is overflowing with grease, you're going to burn the entire building down.
Right. The chef has the context. And the white paper breaks this down by looking at the 3 pillars of legacy tech. First, you have CAD models, computer-aided design.
These are just the visual blueprints, right?
Yeah, CAD is brilliant, but it only knows a component's geometric shape. It knows a pipe is a cylinder. Second, you have learning management systems, or LMS platforms.
Oh, yes. The dreaded corporate training modules.
Exactly. Those hold the theory, usually in multiple choice quizzes, but they are completely divorced from the physical machinery. And third, you have simulators.
And those model the flow of gas or liquid through a system, right?
They do, but they are rigid. They are locked to one specific plant design. None of these 3 tools are the chef.
So what is the missing ingredient? The sources hammer on this concept of judgment.
Judgment is exactly it. Previous tools lacked what EON specifically calls understanding bound to the component. Legacy tools are passive.
So they just sit there waiting for a human to interpret them.
Precisely. But this new library binds the operational reality, the physics, the danger, the human element directly into the digital DNA of the 3D model itself.
Let's get out of the abstract and make this real, because the text provides some incredibly specific, gritty examples of what this encoded judgment actually looks like in the field.
Yes, the examples really sell it.
Take a check valve. The white paper notes that a check valve is never a valid isolation point.
Let's look at the mechanics of why that matters. To a CAD model, a check valve is just a geometric lump of metal on a screen.
Just a shape.
Right. And to a flow simulator, it's just a node that allows fluid to move in one direction. But to a human engineer, and now to this work intelligence library, a check valve is understood in its dangerous context.
Because it operates on pressure.
Yes. If you are doing maintenance downstream, and you use a check valve to block off the flow, a sudden surge in upstream pressure can force that valve open while a human being is literally inside the pipe. It is not a secure mechanical shutoff.
Relying on it could be fatal.
Fatal. And the old software didn't know that. It would let you design a procedure using a check valve as an isolator because it just saw a valve.
Wow. Here are a few other examples that stood out to me. The system knows a disconnect switch is the primary lockout for electrical safety.
Which is crucial context that a basic 3D model wouldn't have.
Right. Or a pressure gauge is the stored energy check before a line is opened.
Again, think about the physics there. Before you unbolt a massive steel flange on a pipeline, you need absolute verification that there isn't lethal stored pressure built up right behind that steel plate.
Yeah, that makes sense. You don't want a geyser of oil hitting you in the face.
Exactly. The pressure gauge is your verification tool. The system now inherently knows that checking gauge A is a mandatory prerequisite for unbolting pipe B. It understands causality.
There is a quote here from Mats Johansson, the president of EON AI Ventures, that captures this gap beautifully.
Oh, I think I know the one you're talking about.
He says, and I'm quoting here, "CAD gave us the shape and courseware gave us theory, but the judgment stayed human and the simulator stayed locked to one plant."
Which brings us to the ultimate hurdle, really. Encoding these safety rules and this operational judgment into a central database is an impressive feat of data engineering.
For sure.
But a database sitting on a server doesn't keep a worker safe. The real test is the execution. How does this software interface with the chaos of the physical world?
Okay, here's where it gets really interesting, but honestly where I have to throw a flag on the play.
Uh-oh, what's the flag?
The press release repeatedly calls this library a living asset, and I have to push back there. Living implies it grows, it adapts, it breathes. Software is usually static.
Usually, yes. It gets updated maybe twice a year if you're lucky.
Right, so isn't calling it a living asset just pure marketing spin? How does a digital file live on a muddy oil rig?
I thought the exact same thing when I first read it. Living is an incredibly bold claim to make.
Yeah.
But when you look at the mechanism of how this system actually deploys in the field, the word starts to make a lot of sense.
Okay, I'm listening.
The white paper outlines 4 core functions that bring it to life. Let's actually put a worker in that scenario you mentioned earlier, out in the rain on a North Sea oil rig, tasked with fixing a broken pump.
Okay, I'm the worker. I'm standing in front of this complex mass of pipes and metal. It's loud, it's slippery. I have a ruggedized tablet or maybe an AR headset. What happens first?
The first function kicks in, which they call recognize. You point your device at the machinery, and the system visually identifies the specific component on site.
So it's using computer vision.
Yes. Let's say you're looking at a pump skid, which is essentially a modular metal frame holding the heavy machinery together. The AI doesn't just say, this is a pump.
What does it say?
It dynamically links that exact physical pump skid in front of you directly to its specific digital twin in the library.
Oh, wow. So it bridges the gap instantly. It knows exactly what I'm looking at down to the serial number.
Exactly.
But I'm assuming it doesn't just pull up a 500-page PDF manual on my screen and wish me luck.
Not at all, which leads to the second function, guide. This is where the judgment we talked about materializes. The system dynamically composes the correct procedure for you, step by step.
Dynamically composes, so it builds the manual on the fly.
Yes. And it's not a static list. It uses conditional branches based on the real-time reality of the machine.
Meaning, if I check a gauge and the pressure is high, it gives me a different set of instructions than if the pressure is low.
Precisely. It adapts to the conditions.
Right.
But here's the most critical mechanism in the guide function. the safety gates.
Safety gates.
Because the library understands relationships, like our earlier example, that a pressure gauge is the check for stored energy. It will actually stop the line.
Wait, how does a piece of software physically stop a worker from turning a wrench? Does it just flash a red warning on my tablet?
Yeah.
Because let's be real, people ignore warnings all the time.
Oh, absolutely. But it goes much deeper than a warning on a screen. It physically or procedurally halts the work. Depending on the plant's integration, the software interfaces with the actual control system.
So it talks to the hardware.
Yes.
Oh.
It can refuse to unlock the digital permit to work required to proceed.
Yeah.
Or it can even refuse to send the electronic signal that unlocks a smart physical valve until the worker inputs data proving the pressure gauge reads 0.
It enforces the safety condition before the next step can even exist. That is wild.
It really is. It takes human error out of safety compliance. It's situational awareness, enforcing the rules.
Wow. Okay, so that's recognize and guide. What's the third one?
The third function is build. This takes us away from the worker on the rig and puts us back in the engineering office.
The text mentions that users can assemble these understood parts into unlimited engineering valid facilities.
Think about the design phase of a new plant, because the library knows how every single valve, switch, and pump works, and crucially, how they are allowed to safely connect. Engineers can use this bounded library to draft entirely new layouts.
Oh, I see. So it's actively looking over their shoulder while they design.
Exactly.
If an engineer tries to virtually connect, like a low-pressure PVC pipe to a high-pressure industrial pump, the system flags it and says, nope, physics won't allow that. The parts don't agree.
Right. It prevents them from designing a flaw into the blueprints before a single piece of steel is ever cut.
That saves a ton of money, I imagine.
A massive amount. But the final function is where the concept of a living asset truly crystallizes. The fourth function is compound.
This is where every job makes the shared library smarter for the next worker, right?
Yes. If we step back and connect this to the bigger picture, this is arguably the most revolutionary concept in the entire white paper.
Really? More than the safety gates?
I think so. Every time a procedure is run on that rainy oil rig, every time a worker encounters a strange edge case, maybe a valve that always sticks in cold weather and solves it, that operational data feeds back into the central library.
Oh, the text has a fascinating phrase for this. It says, this knowledge becomes an asset earned by the enterprise, not rented from a model.
And that distinction is everything. Right now, companies basically rent expertise. They hire a veteran engineer, pay them a salary, and when that engineer retires, all their localized, hard-won knowledge leaves with them.
The company has to start all over again with the new hire.
Exactly. Or, if you look at the software world, companies pay subscriptions to access generic AI models that know a little bit about everything, but nothing about their specific, quirky Texas refinery.
So with the Work Intelligence Library, as your workers solve problems, the system captures their localized expertise.
In real time.
So like Bob in Texas figures out a weird vibration issue, the system learns it, and Sarah in the North Sea instantly benefits from that insight tomorrow.
Yes. The enterprise captures human experience and transforms it into permanent corporate memory. The knowledge becomes an owned, compounding asset that actually appreciates in value over time.
The implications of that are just staggering, but it also raises a massive logistical question for me.
Which is?
If this library learns from every single component in every single job, how do you even begin to build it? I mean, you can't just scan every factory on Earth on day one. Where does the foundation come from?
That is the million-dollar question. You have to start with a rigorously defined scope. And EON AI Ventures is tackling this by moving from the micro-understanding one specific valve to the macro-scaling across global industries.
Yeah, looking at the deployment details, they aren't treating this as a lab experiment. The first edition of this work intelligence library is already being deployed right now with Tier 1 energy and process operators.
They are jumping right into the deep end.
For sure. The press release gives us the exact starting scale. This initial rollout covers petrochemical and oil and gas operations. It features 50 distinct equipment classes and 350 subcomponents.
And this is where we have to highlight a brilliant, deeply technical strategic move by EON. Those 350 subcomponents aren't just arbitrary names that some software developer at EON made up in a vacuum.
Right, they mapped them to a standard.
Yes, they are mapped perfectly to the industry's own ISO 14224 taxonomy. I completely nerd out over this part.
Okay, for those of us who don't have international standardization codes memorized, myself included, why is ISO 14224 the magic key here?
Because it's the gold standard. ISO 11224 is the internationally agreed upon standard for collecting and exchanging reliability and maintenance data for equipment.
Oh, I get it. So it's like how USB-C finally forced all our consumer electronics to talk to each other, but for billion-dollar refineries.
That is a fantastic way to put it, yes. By mapping directly to this standard, EON ensures that this AI speaks the exact same highly regulated, precise language that the industry's engineers and safety regulators already use.
So there's no translation error. Everyone is on the exact same page from day one.
Exactly. Furthermore, the white paper details a pipeline they call EON Ready.
Right, the text says the 3D twins are generated automatically through this pipeline. But how does that actually work without an absolute army of 3D animators?
By using that standard ISO language, the EON Ready pipeline can translate those data codes directly into physical engineering-grade 3D geometries.
Wait, really? It just reads the code and builds the 3D shape.
Yes, it automatically binds the standard taxonomy to a physical shape, drastically reducing the time it takes to digitize an entire plant.
Dan Lidgerskar, the founder and chairman of EON AI Ventures, has a quote that brings this whole scaling strategy into focus. He points out a fundamental truth. He says, every plant on Earth runs on the same few hundred things.
It is the ultimate simplification of a vastly complex problem.
It's basically a Lego set.
Oh, I like that.
I mean, when you dump a box of Legos on the floor, you have thousands of pieces,
Yeah.
right? But only a finite number of actual brick types.
Right, a finite vocabulary of shapes.
Exactly. Once you rigorously define the rules of how an 8-peg brick connects to a 4-peg brick, you can build literally anything. You can build a pirate ship, a spaceship, or a massive petrochemical facility. Because you understand the fundamental parts and the rules, you know the structure will safely hold together.
That bounded nature is the absolute secret to scaling AI in heavy industry. The white paper refers to it as the bounded vocabulary method.
Bounded vocabulary. That makes total sense.
Because the library focuses on understanding the fundamental parts, the pump, the valve, the switch, rather than trying to memorize the infinite chaotic layouts of thousands of different facilities, the exact same intelligence engine can be transferred anywhere.
So you aren't retraining a neural network from scratch for every new factory. You are just handing it the same vocabulary of parts arranged in a new order.
Right. If the system truly understands the physics and safety gates of a centrifugal pump, it understands that pump, whether it's installed in a dusty Texas field or on a freezing rig in the North Sea.
It's universal.
Yes, and looking at their roadmap, they are proving this bounded vocabulary method can jump sectors entirely. Petrochemical and oil and gas is the proven addition today, but the text lists mining, aerospace MRO, which is maintenance, repair, and overhaul, and healthcare as the immediate next steps.
Healthcare is a fascinating pivot. Moving from oil rigs to hospitals feels like a massive leap.
It sounds like it until you apply that bounded vocabulary lens we just talked about. Think about an intensive care unit or a surgical theater.
Right, lots of machines.
It is an environment full of highly specialized, high-stakes, equipment ventilators, gas delivery lines, biometric monitors. It relies on a strict vocabulary of tools, rigorous safety procedures, and intense operational judgment.
Step A must precede Step B, or the patient is in severe danger. Just like checking the pressure gauge before unbolting the pipe flange.
Exactly the same underlying logic. The engine applies perfectly. And every time they map a new industry, that foundational intelligence compounds, making the core engine more robust for everyone across the board.
So we're really looking at a journey from legacy digital catalogs, which basically just showed you a 3D picture of a part to a cross-industry intelligence flywheel.
That's a great way to summarize it.
And it's worth noting, the white paper mentions this library integrates directly with EON's existing spatial AI platforms, Genesis, Field IQ, and Assess IQ.
Yes, the ecosystem is fully connected.
This means they can encode these expert procedures, deliver them spatially to a worker's tablet or headset right there in the field, and then actively verify that the worker did it correctly.
It creates a closed end-to-end loop. Capture the knowledge, guide the execution, verify the safety.
So what does this all mean for you listening right now? Whether you're managing supply chains, working in healthcare, or you're just fascinated by the intersection of AI and human labor, the ultimate goal of this work intelligence movement is capturing the most elusive, valuable resource in any enterprise: human judgment.
It really is the holy grail of industrial management.
It is about grabbing that unwritten expertise, the gut instinct of your absolute best worker before they retire, before they walk out the door to a competitor, and transforming it into an owned, compounding asset. It's making sure the next generation doesn't have to learn by dangerous trial and error, but can start on day one with the accumulated wisdom of everyone who came before them.
It is a profound transition for human industry, no doubt. But looking at the mechanisms we've discussed today, it raises a very important, slightly uncomfortable question for you to mull over.
Oh, what's the question?
If this EON Universal system works exactly as intended, if it encodes all the safety gates, if it literally interfaces with the machinery to stop the line before a worker can make a critical mistake, what happens to human intuition?
Oh, wow. The chef analogy sort of works against us here. If the machine always tells the sous chef exactly what to do and prevents every mistake, do they ever become a master chef?
That is the paradox. If the machine relies on the captured judgment of past experts and actively prevents the next generation of workers from failing, from struggling through a complex, ambiguous problem in the mud and the rain on their own, how will that new generation ever develop their own gut instinct?
That's a genuinely tough question.
Can true expertise even exist without the freedom to make a mistake?
Wow. The pursuit of perfect industrial safety versus the incredibly messy way human beings actually learn and master a craft. That is a heavy, fascinating thought to leave on. Thank you for bringing your insane curiosity to today's deep dive and for joining us as we explored these sources. Keep questioning how the world actually works, and we will catch you next time.